Welcome to this video on the principle of avoiding global functions. Encapsulation is a key concept in object-oriented programming, and it refers to the idea of wrapping code in a context or container. By encapsulating your code, you can improve the maintainability, readability, and reusability of your code. In this video, we'll explore the benefits of encapsulation and how you can apply this principle to your own code. We'll also discuss some common pitfalls to avoid when using encapsulation, and we'll provide some practical examples of how to use encapsulation in C#. So if you're ready to learn more about encapsulation, be sure to watch this video from start to finish. Using global functions is generally considered a bad practice in software development because of the problems they can cause. Some of the main problems with global functions include coupling. Global functions can create tight coupling between different parts of your code, making it more difficult to modify or reuse individual functions. Readability. Global functions can make it harder to understand the flow of your code, as they are not tied to a specific object or class. Maintainability. Global functions can make it harder to maintain and modify your code, as it can be difficult to understand how they fit into the overall structure of your code. Testability. Global functions can make it harder to test your code, as it can be difficult to isolate them for testing purposes. There are several solutions to these problems, one of which is to wrap the function in a context object. This allows you to provide a context for the function and make it easier to understand how it fits into the overall structure of your code. What are examples of contexts where you might use global functions in the first place, but you should not? These include accessing external resources, such as databases or the file system, or accessing system resources such as time or the operation system. On this slide is a bad example in C# of a global function that violates the principle of encapsulation. In this example, the addNumbers function is a global function that can be called from anywhere in the code. This violates the principle of encapsulation, as the function is not tied to any specific object or class and can be called directly. But there is also this good example of a function that follows the principle of encapsulation. In this example, the addNumbers function is a member function of the calculator class. It can only be called on instances of the calculator class, which helps to enforce encapsulation. This makes the code easier to understand and maintain, as the function is tied to a specific context, the calculator class, and is not accessible from outside of that context. Overall, it is generally recommended to avoid using global functions in favor of more modular and encapsulated approaches, such as using object-oriented programming techniques like classes and methods. This can help you create more maintainable and reusable code that is easier to understand and work with. In summary, global functions are considered a bad practice in software development because they can cause problems with coupling, readability, maintainability, and testability. It is generally better to use more encapsulated approaches, such as object-oriented programming techniques like classes and methods, to create more maintainable and reusable code. Examples of contexts where you might be tempted to use global functions include accessing external resources or system resources, but it is better to wrap these functions in a context object to enforce encapsulation and improve the quality of your code.